Well, what about snowpack? So in theory, if we have a lot of water in the snowpack, that should buffer against the effect of summer drought. Well, here we have April 1 snow water equivalent at Bonanza Creek Experimental Forest near Fairbanks, and the June 1 soil moisture percent. And at 5 centimeters, 20 centimeters, and 50 centimeters, there was no relationship between the snow water equivalent of the snowpack just before snowmelt occurs in April and the soil moisture 1 in June, which is typically when summer drought begins. Okay, what about the timing of snowmelt and peak summer NDVI? So here we have the correlation between the remotely sensed day of last spring snow, so for example, April 15th or April 30th or May 10th, and that peak summer NDVI. And for most locations in Boreal, Alaska, which is less than 500 meters of elevation, there was no correlation, or actually a negative correlation, between the date of last spring snow and that peak summer NDVI. At high elevations, there was a positive correlation, and that kind of makes sense because at these high elevations, snowmelt might be occurring May 15th, May 10th, May 20th, and summer drought may be occurring in June, as opposed to these lower elevations, snowmelt may be occurring April 1, April 10th, April 15th, so the chances of it buffering the summer drought occurring in June is a lot less likely at these low elevations. So this graph kind of tells the story of what goes on at low elevations. We have spring snowmelt, and typically, regardless of the spring, we have adequate soil moisture as the soil thaws and snowmelt is seeping into the soil. And then what's really important is what happens in June. Do we get a summer drought? So for example, 2004 we had a summer drought, or do we get summer rains? So for example, in 2003 we had lots of summer rains in July.